Good morning, everyone, and welcome to my presentation. Let me start by saying a few words about myself. Myself, Triti, from BTech first year of CSE department, and my ID goes with 24011A0524. Now, as you can see on the screen, my topic is PQS power and power factor. In this topic, I'm gonna give you a brief explanation of PQS power and power factor. First of all, I'd like to give you an overview of apparent, reactive, and active power. Let's start our topic with active power. Active power is the amount of total electric power in an AC electric circuit which actually consumed or utilized. In simple words, we can say that the power actually used by the load. It is denoted by P and it is also called as true power or real power. The active power is measured in watts. The larger units of active power are kilowatt, megawatt, others, etc. Now let us discuss about reactive power. Reactive power is the amount of total electric power which remains unused in the AC electric circuit and flows back and forth in the electrical system from load to source and vice versa. In simple words, we can say that the power that flows back and forth between the source and load. It is denoted by the letter Q. The units are volt ampere reactive, that is VAR. The reactive power in AC circuit may also be defined as a product of RMS values of voltage and current with the sign of angle phase angle. That is Q is equals to VI sine alpha. The reactive power is also known as wattless power or quadrature power. For an inductive load, the reactive power consumed is the lagging reactive power and the consumed by the capacitor is the leading reactive power. Now, let us go with apparent power S. Apparent power is a term used in electrical engineering to describe the apparent power in an electrical alternating current system. It is made up of active power, that is the power actually used, and the reactive power, the power not used for the work. It is denoted by the letter S. Apparent power is defined as the vector sum of active power and reactive power. Now let us know to know the relation between PQS, we need to know about power triangle. Power triangle. Power triangle is a graphical representation of the relationship between the true power and reactive power and apparent power. So in the diagram given, we can see hypotenuse as apparent power, the base or adjacent side as real power, and opposite side or height as reactive power. Now, in this diagram, we can clearly illustrate the relationship between the P, Q, and S. From the given diagram, we can conclude that S square, that is apparent power whole square, is equals to real power square plus reactive power square, and power factor, that is power factor. Power factor is a measure of how effective the incoming power is used in an electrical system. The high power factor indicates that the power supplied to the electrical system is effectively used. A system with low power factor does not effectively consume the incoming electric supply and results in losses. So power factor can be given as cos theta, that is P by S. Now let us know about importance and significance of power factor energy efficiency. This is the main point and this is the most likely point to be discussed. Higher power factor reduces energy loss and resulting in lower electricity bills. Next, system performance. Improved power factor enhances the performance of the electrical equipment and reduces voltage drops. By this, we can know that power factor plays a major role in safeguarding the equipment. So, because of this, we need to increase the power factor to the level we can. Next, as we already discussed, power factor is the cause of angle between apparent power and real power. That is the angle between P and S in the power triangle. This is a formula that we need to be followed. Next. Factors which are affecting the power factor. First, inductive loads. Inductive loads lowers the power factor. Examples, motors and transformers. Capacitive loads raises power factor. Examples are capacitors, some electronic devices. We have advantages, we need to have some disadvantages. So let us know the consequences of low power factor. First one, increased energy consumption. If the power factor is low, higher energy loss is faced. That is due to reactive power, leading to increased electricity bills. So, as we discussed earlier, we need to increase the power factor to reduce our electricity bills. And voltage drops. Reduced voltage at the load causing performance issues with equipment. Overheated equipment. This also is for the safeguarding of the equipment. Increased current can decrease the power factor leading to overheating of the equipment. Next, improving power factor. That means to increase the value of power factor, let us know three methods or techniques. First one, power factor correction. We can improve the power factor by installing capacitors in parallel with inductive loads to compensate the reactive power. Second, using high efficiency equipment. Replacing older inefficient equipment with newer, more energy efficient models can increase your power factor. Third, load balancing. Distributing loads evenly across the system to minimize reactive power flow. So let us know the formulas of P, Q, S and power factor. First, active power. Active power P equals to VI cos theta, where V is voltage, I is current, and theta is the phase angle. Reactive power Q equals to VI sin theta, where V is voltage, I is current, theta is phase angle. Now cos factor, power factor is equals to cos theta is equals to active power by apparent power, that is P by S. So let us know some applications of these. Industrial facilities. Power factor correction in factories with large motors to reduce energy consumption and improves efficiency. So this the major thing is we need to increase the power factor to safeguard our equipment and also decrease our electricity bill. Commercial buildings. Optimizing power factor in office buildings to reduce energy bills and improve the power performance of lighting system. So by this, I want to end up my presentation. Thank you.